Okay, the second question I wanted to just help you out a little bit on is going to be part E on this question, which is on the back here of your homework for this week. So homework 13, flipping over to the back, we're looking at this one. Okay, in order for us to do part E, I'm going to have to do a little bit of part A. So hopefully you already did this on your own, but part A, you're finding G of 3. Okay, and actually I'm not going to do it for you. I'm just going to tell you that G of 3 should come out to be 7. Now the reason why is because you'd be setting up, I guess we'll do it. Integral from 0 to 3 f of t dt. And when you shape that in your graph, you're going to notice that it's a little bit of a weird shape. It's like almost a triangle, but then this whole wing is cut off. So there are kind of two ways for you to address that. Actually, there's a bunch of ways for you to address it. What I'm going to do is I'm going to count this middle part. Okay, that's obviously 4. I'm just counting the boxes there. It's a square. It's 2 by 2. And then what I'm going to do from there is find the size of one of these. And then I'm just going to times it by 3. So if I'm looking at that chunk, that would be 1/2. My base is 1, my height is 2. So 1/2, 1 times 2 is 1. So that means that this part is 1, this part is 1, and then this part is 1. Because you're dividing these into congruent triangles. Good? So I have 1, 1, 1, and 4. That makes 7. Okay, fast forward down to part F. Okay, part F says to find the average rate of change of G on the interval from 0 to 3. Then it says, where does G prime equal the average rate of change? Okay, you can cross this out. Okay, we're finding where that happens. So, from 0 to 3, I want the average rate of change, that's the AROC. And remember that AROC is usually f of b minus f of a over b minus a. However, I want the average rate of change of G. So that would be G of 3 minus G of 0 over 3 minus 0. Now this is where you have to remember as well that G of 3 we already found. We literally just found it. It was 7. We found it right here in part A. So G of 3 is going to be 7. However, G of 0 I have not found yet, so I'm going to actually have to go back and find that. So I'm going to come up here to the top and I'm going to find out what my G of 0 is, because this is unknown at this point. So come up here to the top. G of 0 is going to be the integral from 0 on the bottom, and then if my x is 0, it's also a 0 on top. Well, the integral from 0 to 0 comes out to be 0. Okay? So come down here back to your average rate of change. It's 7 minus 0 over 3 minus 0, which comes out to be 7/3. Now notice this isn't position, velocity, or acceleration, so we don't have to worry about units. So find the average rate of change. It's 7/3. Then it says, where does G prime equal the average rate of change? Okay, well let's think about that for a second. So if I want G prime of x to equal 7/3, remember that G prime of x is going to be the derivative of G of x. So if G of x is the integral from 0 to x, then G prime of x would be the derivative of that. Remember, I plug my x in, it's going to be f of x. So really, I don't want just G prime to equal 7/3. I want f of x to equal 7/3. And remember that f of x is really the y value in the graph. So 7/3 is 2.33333. Okay, so when I look at my graph, I'm looking to see where it hits that value. So I'm going to come up here to my graph, and I'm going to draw in a flat line at 7/3, which is 2 1/3 left over. So here's 1, here's 2, here's about 2 1/3. Okay, so the question is, where does my graph f of x equal 7/3? Well, I can see in my graph that it hits twice. It's going to hit once on this side and then once on this side. So there are a couple different ways for you to think about this. The first one would be to kind of think about the slope and go from there. But the second way for you to do it which is what I'm going to do, is to write the equation of this line, pretend like this line is what I'm trying to find, and I want it to equal that. Well, let's write the equation. It'd be y equals mx plus b, right? M is your slope. What is the slope of this line? I'd count rise 2, run 1, rise 2, run 1. So my slope is y equals 2x. And then plus b would be the y-intercept. Well, I can see the y-intercept is 0. And if I want to know where this line hits 7/3, I'd set those equal to each other. So I'd let 2x plus 0, I'm not going to put that, equals 7/3. Well, then I'd multiply by a half on both sides, and x is going to equal 7/6. So that's my first answer. Now, if you were to try to solve this, you could see that that'd be 1 1/6. So this is 1 right here, so then I'm over 1/6 from that. That's my first intersection point. So I'm going to come down here and put at x equals 7/6 and the reason I know that there's a second one is because I just looked at the graph, right? I also see that I hit 7/3 again over here. So I'm going to do the exact same strategy that I did last time. I'm going to extend my graph backwards, write the equation of that line, and then I'm going to set it equal to 7/3. Now remember, we're still sticking with the y equals mx plus b format. So if I'm looking at this line segment right here, I can see my slope is down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. So it's going to be y equals negative 2x. And then I need to find my y-intercept. Okay, well think about it. If I left off here at 4, then I'd go up 2 backwards 1. That'd put me at 6, at a height of 6. Then I'd go up 2 backwards 1 again. That would put me at a height of 8. So then from there, I'm going to take the equation of that line. I'm going to set it equal to the value that I want it to equal, and then I'm going to solve. So I'd let negative 2x plus 8 equal 7/3. And then a really easy way to solve that, I don't know if y'all learned this, it's kind of a shortcut to get rid of fractions, but I'm just going to times everything by 3 to get rid of this fraction here. So now I have a negative 6x, a plus 24, and then 7/3 times 3 is now just a 7. So that I can minus my 24 across. 7 minus 24 is going to give me negative 17. And then I'm going to divide by negative 6. So my other value is going to be 17/6. And notice those negatives are just kind of crossing out with each other because it's convenient. Now, if you were to think about that, okay, 18/6 is 3, so it's basically 1/6 before 3. So if here's 3, I can see that it crosses just barely in front of that. So that makes sense in my graph. Okay. All right, good job.